Good afternoon, everybody. My name is Ethan. I am an educator with the Artesian Alliance, which is the Cheehaw Park and Zoo, the Thronatisca Heritage Center, and the Flint River Aquarium here in Albany, which is where I am right now. Today, I am going to talk to you guys about tides and waves and how they all affect the beach and why our beaches are disappearing. So, to start, let's talk about tides. What is a tide? Well, a tide is is what happens whenever the gravitational effects of the moon and the sun and all of the other celestial bodies play out on Earth. So imagine you have the Earth in a ball here, and the moon is circling around the Earth. Well, whenever at the spots where the moon is, um, the gravity of the moon, because the moon is very large, the gravity of the moon is going to affect the tides on Earth, the water that's on the planet. So the water is going to bulge out and stretch a little bit because the moon's gravity is pulling it. And because it's stretching out on the one side, on the other side of the planet, it's stretching a little bit as well. That's because the water's being stretched. Um, it's a little bit of a kind of a strange idea that the moon can make a high tide on the opposite side, but it's just because you're kind of it's like if you have a ball and you're just stretching the ball a little bit. That's what's happening with the water on planet Earth. Now the sun also affects the tides. The sun is a little bit less than half as strong as the moon is when affecting tides. So as the moon's rotating around the Earth, the sun is there and the Earth's rotating as well. Whenever the moon and the sun are kind of in the same spot, you're going to have what's known as a king tide, which is whenever the tides are just even stronger because the sun's pulling at it and the moon's pulling at it, and they make it really strong. It happens whenever the sun and the moon are on the same side, or whenever the sun and the moon are exactly opposite each other. The opposite of a king tide is called a neap tide. It's a very, very low tide. And it's what happens whenever the sun and the moon are kind of perpendicular to each other. So the sun might be pulling the water one way while the moon is pulling it a different direction, and they just aren't meshing at all. And so you've got very low tides. So the moon travels around the Earth at, it takes it 24 hours and 50 minutes to travel around the Earth. And so that's how long our tides last. We actually get two tides because I said you've got where the moon is, and then you've actually got the opposite, both spinning around. You've got two tides. And so if you're out on the Atlantic coast, for instance, say you're near Savannah, you are going to get a high tide every 12 hours and 25 minutes because it's twice for that full rotation of the moon around the Earth in 24 hours and 50 minutes. If you're on the Gulf Coast, you're only going to get it once. And that's just because of the nature of the Gulf Coast and the way that the tides hit it. The moon is technically at a slight angle to the Earth. It's at a 5-degree incline to the Earth's incline. So it doesn't exactly orbit exactly the same way. It wobbles a little bit. And because of where the Gulf Coast is, you're only going to get one high tide per day and one low tide per day. That also occurs in places like China. China, the entire a decent chunk of the eastern coast of Asia doesn't get two tides; they only get one, and it kind of depends on where you're at, I think. So tides affect how big the waves are going to be. Now let's talk about waves themselves. And we're actually going to take a look at how waves work in this tank behind me here. That's why it's set up. So waves are caused on the surface near the coast. They're caused mainly by wind. You get some strong winds, and they're hitting the waves, and it's causing the waves to, it's causing the water to undulate and roll. And what's really happening is the energy under the water is kind of just rolling. It's like a big rolling pin, and the water's just getting affected by it. It's getting lifted up as this rolling pin rolls underneath it. And it'll roll and roll and roll until it collides with something, or it maybe hits another wave that's going in a different direction, and they sort of stop. Um, so whenever it gets near the coast, though, um, whenever it starts getting shallow, that's whenever you see waves break, right? You get all that foam and fizziness as they crash, and that's because that sort of rolling pin hits land, and so it just collapses, and so the water, having all that momentum, crashes into the beach. Um, so we are going to talk about how water affects the beach. Um, so waves will break on the beach, and actually, depending on where you're at and what time of year, waves might affect the beach in a slightly different way. So, in winter months, on the Atlantic coast, in winter months, the beaches are smaller. They get smaller. The water's closer to the dunes, and that's because not just because the water gets higher or anything. It's because the beaches themselves get pulled out more. The colder weather brings choppier water, and you usually get a lot more storms in late summer into the fall, all the way through November is hurricane season. It's July until November. And so you'll get storms and heavier, choppier waters, and all of these factors will pull sand away from the water. But in the summertime, you get pretty much the opposite. The waves tend to get calmer in the summertime because of the warmer weather, and you get the North Atlantic current, which is this really, really big ocean current out just off of the coast. Will get closer to the shore, and it'll bring all that warm water in, and it will cause all of this sand that got pulled out to get pushed right back onto the shore. Now, not only that, but down the coast, actually technically up the coast, it moves north. Um, Sand gets pushed up the coast because if you've got a wave coming in, it's coming in at a slight angle, and then it comes back out at a slight angle, and so it zigzags its way up the coast. And so all of that sand will get pushed up the coast as well. So enough of me talking. Let me demonstrate some of it. So the first thing that I'm going to demonstrate for you guys in this water pool behind me, as you can see, it's a little bit difficult to see, but right here is the water line. And then you can see just above the water line, I've got this beach here. This beach right here is made out of fine gravel, but depending on where you are, it might be sand, it could be gravel, it could be all kinds of stuff. Sand is a very, very broad kind of thing. So we're going to be looking at this. I'm going to make some waves. The first waves that I'm going to make are going to be very calm waves, and you're going to see how some of the sediment, if you watch right around here, some of the sediment is going to kind of move back and forth, but for the most part, it's going to stay pretty much where it is. Whenever that's finished, I'm going to do a demonstration of some rough waves, some choppier waves, maybe a hurricane or a very large beach storm is happening. And you'll see how the sand and sediment just gets pulled further and further out to sea because of that. So let me do my demonstration. Like I said, the first one's going to be warmer, nicer, calmer waters. So let's get you nice and close so you can appreciate the scene. Let's push some of that sand up. All right, so like I said, I'm going to do some light waves. All right, you might have been able to see that a little bit. the sand and sediment was kind of moving a little bit back and forth on the coast as these waves hit it, but not a whole lot happened, right? So now I'm going to show you what it looks like whenever something a little bit choppier hits. I think you could see that pretty well. The sand was getting pushed up and then rolled all the way back. So what actually happens on our coasts is we have things called barrier islands, and they're just these very small kind of sandbar-ish islands. They're usually very thin and pretty long, and waves will hit those and they will come up and crash up in a storm, and they'll either pull all of that sand back with them, or they will crash over the island and actually kind of roll the entire island over itself, and the island will move closer to the shore. So you can actually see that a lot. Some islands, I know there's an island near Wilmington, North Carolina, that moves a whole 18 inches every single year closer to the shore, which is absolutely crazy that something like that could move so much. It's almost astounding. Um, but these waves cause a lot of motion to happen. This is a very, very small example. Imagine an entire beach, a whole beach, just moving like that constantly as waves are hitting it. You will get millions upon millions of cubic feet of sand getting moved off this beach and out to sea. Now, normally this wouldn't be a problem because uh, this would only happen a few times out of the year, and for the rest of the time, sand would slowly get deposited by calmer waves. But there's a couple of things that are affecting our beaches right now that are making all of our beaches disappear. They're disappearing at an alarming rate. Um, and so we have been trying to combat it for years, we as a population. Um, but there are three big issues that need to be addressed in order to combat these problems. These three reasons why the beaches are disappearing so much. So reason number one, and this is the biggest one, is that there have been way more storms now than there have ever been. Just they get more severe and they get larger every single year, and uh, there are all kinds of reasons for that. The North Atlantic current is on our Atlantic coast. The thing that I mentioned, that's just this big, heavy stream of warm water that's moving its way from the Gulf Coast all the way up the Atlantic coast. It's moving further and further out. So we're getting this weird mix of cold and warm water closer to our shore now and into the middle of the water, and it's making storms happen because hurricanes are formed by a mix of cold water and warm air. So they mix together and cause all kinds of problems. Um, so we're getting that. Um, the temperature difference between summer and winter is also getting more. So we're getting more extreme storms on our coast. But all of these storms are causing all kinds of damage because these choppier waters hit the coast and drag all of the sand in, and all of the sand in, and all of the sand in. The average for the last 30 years has been about 12 hurricanes per year, with 3 large ones and 9 or so smaller named hurricanes. And only about 3 will ever make landfall. But in 2020, we had 30 whole named hurricanes. That is an astounding number. That is 2.5 times the average for the last 30 years. And in 2019, we had a whole bunch as well. We had way more than the average as well. And it doesn't look like 2021 is going to be any different. We're going to probably get a whole ton of storms now as well. Um, the storms are also getting more dangerous. So these storms are hitting the coast and battering down all of the sand and dunes and all of that stuff that we've got and dragging it all out to sea. The other thing that's happening um, is that our sediment, the sand, it's not getting redeposited. It's just disappearing. So normally, you get sand from a number of different things. So after a little while, the sand will slowly get built back up onto the shore because of the way that waves work. They're pushing that sand up. But um, the other major thing that beaches need is actually rivers, believe it or not. Rivers move all kinds of sediment downstream, and that sediment will end up on beaches and it will roll up the beaches and give these beaches new sand all the time. But most of American riverways are dammed. They're dammed over, so a lot of that sand and sediment doesn't move once you've got a dam, because if you've got sediment moving along, oh, it hit the dam, it's stuck there. It's actually a really big issue. We have started to try to solve that issue by just literally taking whole dump trucks and filling them up with sand from a lake that has a dam on it and just hauling it towards the coast. And the third problem that has been happening is that humans have been accidentally or on purpose, I guess, increasing erosion. They've been making it go faster. And I'm going to show you a couple of the ways that we have accidentally made our beaches disappear even faster here, and some of the ways that we can fix it and challenge it. So way back in the day, a lot of people went out to these islands and these beaches and were like, oh, this is wonderful. This is lovely. I want to build a house right here. So they would build a house right there on the beach, and then they would realize the beach moves a lot. The sand moves a whole lot. And they're like, oh no, my house is going to get destroyed. So they would build things called seawalls, which are still used today, but they're not as common. And seawalls are exactly what they sound like. They're just these big walls built to stop the ocean from destroying a house on the other side. The problem with seawalls, though, which is what I'm going to demonstrate here in a minute, is that they might do more harm than good. And I'm going to show you why here. So I'm going to put a seawall into this, and I'm going to batter it with some hard waves, and we're going to see if the seawall stays. What happens with the seawall? So give me 1 second here, and I'm going to set up this seawall. So as you can see, I have set up a seawall in the form of a piece of wood. And this seawall is going to protect everything on this side. It's not going to get battered with waves and erode as fast, but we're going to see what it does to the entire process as a whole here. So I don't know if you guys noticed that, but on this side of the seawall, on the actual sea side of the seawall, all of that sediment has gotten eroded a lot quicker. Um, That's what happens with the seawall. So these waves crash up against the wall, and all of that momentum has to go somewhere. So it gets sprung right backwards. So it just drags all of this sand away. So on beaches that have used seawalls to try to protect towns and cities and whatnot on the other side of it, they've actually found that their beaches have disappeared even faster. So seawalls are not a very great strategy. Um, so the next strategy that people have tried to try to prevent the waves from pulling all of this stuff out are things called wave breakers. And so what they are is they will literally build a mound of something out a little ways from the beach itself, and then whenever the waves come in, because the waves are all of this momentum, the waves will literally break on this, and then it'll be all dissipated whenever it reaches the shore, or at least that's the logic. We're going to see if it actually works here. So give me 1 second. I'm going to take off my seawall, set the beach back up, and I'm going to put a wave breaker in there. So my wave breaker today is going to be a saucer. And you can see that right there. I placed it just out. Wave breakers don't normally sit over top of the water. What they do is they sit really close to the top of the water. So whenever the waves hit them, but uh, this is what I've got for today. So we're going to use that. So what just happened? The wave breaker, I was sending waves that were just as powerful as the last time. They were pretty strong waves. And if you noticed with the seawall, the waves were causing huge crashes, big splashes, and a lot of mess. Whereas with this wave breaker, they were sort of crashing against the wave breaker, but whenever they got to the shore, they didn't cause nearly as much erosion, as you can tell by my little beach right there. So they're attempting to dissipate the wave before it makes it. So instead of this huge amount of energy hitting the water and then pulling all of that sand back, it's just breaking on that, which is much more solid. Now, a slight issue with that would be time. Over time, the wave breaker, while it's definitely more stable than the sand or sediment on the beach, it's eventually going to wear out. So you'd have to replace it or think more forward. It also isn't a great strategy if you have a harbor. So if you're trying to break waves here and you need ships to come out, you need to plan a space where ships can go through. That's a good channel, because otherwise you're just going to have your harbor locked in and no ships are going to be able to get out because it's too shallow just outside. So there's a number of different kinds of wave breakers that people are using. Um, I'm going to show you guys just one classic example of a wave breaker right here. It's rocks. People are just putting huge boulders out in the sea. And they function pretty much the same way as I'm going to demonstrate here. So I am going to put a bunch of rocks just off the coast here, and we're going to see how the waves affect that now. So It might be hard to tell, but I have several rocks now just hanging out just off the coast there. And so now I'm going to send some waves in, and we're going to see how this kind of wave breaker works. So you probably might have noticed that the waves looked pretty much exactly like um, they would if they were calm, but I assure you, I was sending pretty strong waves through. So what happens is a lot of times piers will build sort of these rock islands just off the coast. And actually, one strategy that some places have been using is putting oyster beds out in places like sounds and estuaries because oysters are native. They are excellent filters, so they clean the water, and they work just as well as rocks for breaking waves. So um, we have looked at what a tide is. We've talked a little bit about how tides work, how the moon affects the tides, and it makes the earth a little bit, it bulges the earth out as it spins around on both sides. We've talked about how the sun also affects tides, and technically every celestial body affects tides. It's just the sun and the moon are the two biggest for us. Um, we've talked about how waves sort of work. They've got a motion to them. Um, and how whenever that motion reaches, whenever that unstoppable force meets the very movable object that is our beach, it sends all of that sand and constantly moves it back and forth. And how we've got a couple challenges to face here because with the increase in storms and some varying success with fixing our beaches um, and keeping them alive, we've got a difficult task ahead of us, which is keeping beaches alive. Um, so right now, all across the nation, people are refilling beaches. You might have seen people talk about it before. Refilling beaches means that they are literally dredging up sand from somewhere. Sometimes they're getting it from upstream, like I just talked about, like from lakes and reservoirs. Most of the time, they're dredging it from a little bit further out and hauling it in on a big barge and just literally shooting wet sand from a huge tube onto the beach. I've actually seen it before. It's very, very cool. And so they are refilling beaches. Um, and this is a very expensive strategy, but it's the one that's been working the best for us. Um, and it's a great solution until we have come up with a more long-term strategy. Uh, but we literally just dump tons of sand onto the beach and try to refill it. But some challenges to that, you've got to be really careful because beaches are estimated to lose as much as 80% of their sand every single day. 80% of their sand gets moved somewhere else from any given spot on the beach. And so what they need to do is engineers need to think about where they should refill their sand, what parts of the beach they should cover with sand and build really high so that it will get taken in the long term and refill the rest of the beach. Um, and so these are all things that engineers are figuring out and things that are going to be a challenge for us moving forward. So I hope you guys enjoyed this sort of look at how waves affect beaches, how the tides work, and how the endless constant motion of them is leading to all sorts of engineering challenges for us who really want to enjoy the beach. And some of us even want to do things like build houses near the beach, but there are some challenges that we need to address to that and ways that we can work around it and live in harmony with the ocean because the tides are never going to stop. And so we need to figure out ways to work with them instead of fighting them all the time. Does anybody have any questions? All right. Well, thank you guys for coming and have a great day.